All right, welcome to Chemistry with Taylor E. We are going to predict products of double replacement reactions here. Double replacement reactions are one of the 5 types of chemical reactions, but in this video I'm just going to really focus on double replacement and the method of that, okay? I do want to mention that predicting products of chemical reactions can get very crazy and confusing. But you always need to come back to 2 major rules in predicting products, okay? The first one is if a compound forms, then you need to balance charges, right? What that means is, let's say I get aluminum and oxygen together, right, on the product side. Then that means I need to balance charges, right? Aluminum is a +3 charge, oxygen's a -2 charge, so with my drop and swap, Al2O3, right? So I need to just make sure that I balance my charges if a compound forms. The only other option is a single element forming, and if a single element forms, then you need to check for diatomics, okay? The diatomics, just not explaining it into too much, right? You have hydrogen, nitrogen, fluorine, oxygen, chlorine, bromine, and iodine. These are your elements that only exist in 2, so if they are by themselves, not in a compound, by themselves, then they have to have that 2 subscript on them, okay? So if you can get these 2 rules down, you've got a good chunk of predicting products and the most common mistakes that students make. As always, make sure you balance your chemical reaction last. For the time of this video, I will not be balancing the chemical reactions in total because I just want to focus on the skill of predicting products of double replacement reactions, okay? All right, so just some vocab. Reactants are on the left, products are on the right. Reactants react to produce products is a saying that you can keep in mind if you need help remembering them. And again, double replacement reactions are when you have a compound and a compound. You're going to keep your A and C still, right? So notice that my A and C are still in the front of all of these molecules. And as what I did was I switched B and I switched D, right? So these would be my nonmetals or my polyatomics, right? These are your polyatomics, right? Nitrate, nitrite, carbonate, chlorate, right? You get the point. Those are your polyatomics. Long story short, though, keep the metals still, switch the partner on the back end, okay? And then, again, we are going to be getting compounds, right? So that means to follow the 2 major rules, we need to be balancing charges over and over and over and over again, okay? In a double replacement reaction, you're not going to have a single element that forms, so we don't have a need for diatomics in this lesson. But again, it is going to be super important that we balance our charges every time we form a new compound on the product side, okay? I'm going to be doing both word versions and formula versions so that you have a mix of both because I've seen teachers ask it both ways. So let's start with number 1. We have aluminum iodide and potassium chloride. If I were to do the word version of it, right, aluminum stays still, potassium stays still, and I'm going to switch, right, iodide and chloride. So my products would become aluminum chloride and, let me not do the and sign, let me do a plus sign. And so I'll do the arrow as well if I had more room. Aluminum chloride and potassium iodide, right? So you see, all we did was we just kind of switched their partners, right? If I were to have to turn this into formula, which most likely your teacher will require that, let's go ahead and create the formulas for this reaction. So aluminum is Al. It is a +3 charge. Iodine is a -1, so dropping and swapping, we get Ali3 plus potassium chloride. That's a +1 and -1 charge on the periodic table, so it stays just like that. We're going to have our arrow for the producing sign, aluminum chloride. So Al, again, +3, Cl -1, so AlCO3 plus potassium, K, iodide, I, +1, -1, so that's good, okay? Now again, this reaction's not balanced. I'm going to show you what I mean by that for this one only, but again, I will not be balancing all of these reactions just for the sake of time. But you can see I have 1 Al, 3 I's, 1 I, so I need a 3 here. That gives me 3K now, and I have 3 Cl's over here, so to finish that out, I need a 3 in front of KCl on the left side. So this would be my final answer with predicting the products and having it completely balanced, okay? All right, let's do number 2. I have calcium hydroxide and ammonium chloride, right? So calcium hydroxide. So calcium and ammonium stay still. I'm going to put my word, right? Your teacher might require you to write yield if you're doing the word format, so just keep that in mind. So calcium was with hydroxide. Now it's going to be with chloride. There we go. And Ammonium, that's a polyatomic ion, not an element, but a polyatomic, that is NH4. and ammonium hydroxide. So again, just kind of switching their partners around, okay? Let's go ahead and do the formula version. So calcium is Ca, hydroxide is also a polyatomic. It's a sneaky one because it ends in "ide." Most polyatomics end in "ate" and "ite," but hydroxide does end in "ide." And hydroxide is OH, okay? And it has a -1 charge. So I need 2 hydroxides to balance out calcium's +2 charge. So CaOH2 plus ammonium, NH4, that's a +1 charge. Chlorine is a Cl, -1 charge. So those are balanced. That's good. Produces calcium chloride. Ca is a +2 charge. Chloride is a -1, CaCl2. And ammonium, as we said, +1 hydroxide. Oh, I don't need the parentheses around hydroxide because when you only have one of it, you don't need parentheses, okay? Because this is a +1 and a -1 charge. And just to reiterate where I'm getting these charges from, right? On the periodic table, there's a trend, right? So like all of the elements in group 1 is a +1 charge, +2 charge, right? +3, +4, -3, -2, -1, 0, right? So ion charges, hopefully up until this point, you have a really good understanding of where I'm getting those ion charges from. But if not, this is the pattern, and I do have a video on it, so I would recommend you go check that out, okay? All right, so here we go. Perfect. And again, go ahead, if your teacher's requiring it, I would go and balance this chemical reaction, okay? Which again, I have a separate video on balancing chemical reactions. Number 3, we have magnesium bromide and silver nitrate. To continue the word equation, I would say yield, right? So again, magnesium stays still, and we're going to switch its partner. It was with bromine, now it's going to be with nitrate. So magnesium nitrate. And I would say silver was with nitrate, now it's with bromide. So silver bromide. Okay, to do the formula version, magnesium is Mg, bromine is Br, that's a +2, -1, so MgBr2, plus silver nitrate. Silver is Ag, that's a +1 charge. Nitrate is NO3, -1, that ends in 8, that is a polyatomic, okay? That's a polyatomic. If you have to memorize it, then hopefully you have it memorized. Otherwise, go look it up on a polyatomic ion list that's provided to you. It should be attached to your periodic table somewhere. That's a -1 charge. That's a +1, -1, so those cancel. Those are balanced out. Yields magnesium nitrate. So MgNO3, 2. Why do I have 2 on the NO3? Because magnesium is a +2 charge, nitrate's a -1, dropping and swapping. I need to do parentheses around the NO3 to show that I have 2 of them, okay? And then lastly, silver bromide. Silver is Ag, it's a +1 charge, and bromine is a -1 charge, so those cancel out just like that, okay? All right, awesome. Moving on to number 4, iron 3 chloride and lead 2 nitrate. So these are Roman numerals, and you're like, what in the world is that? If this is your first time seeing it, that is the charge of a transition metal, okay? The transition metals are the central part of the periodic table, right here in the center. I call them the fake people of the periodic table because they act different depending on who they're with, right? It's a metaphor. But it was why we need these Roman numerals is because we have to say what the charge is for that transition metal in whatever problem that we're doing. So this 3 here for the Roman numeral is telling me that iron is a +3 charge, just like this 2 here is telling me that lead is a +2 charge, okay? So iron, chloride, and lead 2 nitrate, so those are going to yield in word format. Iron, right? It's still going to be the 3 because that stays with it, nitrate, and lead 2 because that charge stays, chloride. Okay, now let's do the formula form. So iron is Fe, they're telling us it's a +3. Chloride on the periodic table is a -1. It's ide, which means it's just the Cl element. It's not a polyatomic, it's just the element. Dropping and swapping, you get FeCl3. Plus lead, that's Pb, it's telling me it's a +2 charge. 8, that ends in 8, that's a polyatomic, that's NO3. It's a -1 charge, so I need to drop and swap to give me that 2 here on PbNO3 too. I'm going to draw my arrow. I have iron, which is an Fe, that's a +3 charge, nitrate, NO3, drop and swap, NOFe, NO3, 3, and then plus lead is Pb and Cl2, right? Because this is +2, -1, dropping and swapping to balance that out, okay? Awesome. All right, number 5. We're just going to do the formula form here for number 5, 6, and 7, not word format anymore. So we have Ki and NaBr. So again, K and Na, those are going to stay together. So K was with I, now it's going to be with Br. That was a +1, -1 charge, right? So that's good. We're good there. Plus, Na has to be first. Was with Br, now it's going to be with I. That is also a +1, -1. So those are all set to go. There you go. All right, number 6. We have MgSO4 and NH4Cl. So again, Mg and NH4. NH4 is a polyatomic. It needs to stay together. And Mg is just an element, stays together like that, and swap their partners. Mg was with SO4. Now it's going to be with Cl, right? So MgCl, balance your charges. That's a +2, -1, so MgCl2. And then NH4 was with Cl. Now it's going to be with SO4. And again, go look those up. NH4 on the polyatomic list is a +1. Sulfate is a -2, so I need to put this NH4 in parentheses to get that 2 down here. So NH4 in parentheses 2, SO4. Okay? All right, last one, number 7. Pause it if you're feeling up for the challenge. Try this one real quick. All right, so we have PbNO3 and SrCl2. Again, metals, right? Pb and Sr, keep them still. Switch their partners, okay? So Pb was with NO3, now it's going to be with Cl. I need to know the charge of Pb. The problem is lead is a part of that transition metal trend, right, continuing on, where the charge can change. For example, if you reference this, Pb lead, you can see it could be a 2 or a 4, right? It can have either charge. And so we need to figure out which one it is in this problem. So we have to do some decoding here. Nitrate is a -1 charge. How many nitrates are there? There's 2 nitrates. So that's a total of -2, right? So that means this one Pb has to be a +2 to have this balanced out. So Pb is a +2 charge in number 7. So that means Cl being -1, you need PbCl2, okay? All right, and then plus Sr stays still, and it was with Cl. Now it's going to be with NO3. I'm just bringing over NO3. I'm not bringing that 2 over. Just nitrate, okay? Just NO3. Now let's balance our charges. Strontium is a +2 charge. Oh, I'm thinking it's in the second column. Yeah, okay. Strontium's in the second column on the periodic table. So it's a +2 charge. Nitrate is a -1 charge. So we do need to drop and swap. NO3 comes in parentheses, and that 2 carries down, okay? All right, there are some double replacement reactions and predicting the products of them. See you on the next one.